So here's our topic. Coupled reactions are when you're taking two reactions and putting them together for some end goal. Here's our objective. Unfavored reactions, it's got a negative delta G, positive delta G, doesn't look good. How are we going to make it happen? All right, how are we going to get it done? Another way to think of it is how to make something that's got a negative, how to get it to happen, all right, when it's got a positive delta G. One of these types or one of these ways you're really already aware of, in that in plants it needs glucose, and it turns the carbon dioxide and water into glucose. This reaction takes a lot of energy. Where does that energy come from? It comes from the sun. All right, so I have a reaction, it's got a positive delta G value, so that means it's unfavored thermodynamically. One way to get around this is use an energy source, and that's just what we saw in photosynthesis. Your energy source doesn't necessarily have to be the sun. It could be like a battery or a current, like an outlet. Today's with coupling, you're going to couple it with a thermodynamically favored chemical reaction, one with a negative delta G. This is found in the process of smelting. Just remember to follow Hess's law when you do this. Right now, I want to go over the energy source manner first. And with photosynthesis, you've got this positive delta G. Where does the energy come from? It comes from the sunlight. Lithium ion is another very common time where you have an energy source to overcome a positive delta G value. All right. To turn this back, I'm going to need 293 joules of energy, kilojoules per mole. So it means this thing's really stable. All right. How does it happen? All right. How do we make this thing do it? Well, we plug in energy. All right. We overcome it. And this comes from when you charge your battery. You plug it into electric, like the wall in our phones and so forth, and in my computer. Hopefully you're using like solar panels to do it. Now, before we go through a coupling example, I want to define coupling. And there is a requirement when you couple reactions. You want them to have a common intermediate. Couples requirement. Remember Hess's law when you do this. And Hess's law is like when you add up reactions, there's three things that you're going to do. In this case, Hess's law applies to delta G values. If I have several steps, the delta G is going to be the sum. If I reverse anything, I just change the sign of the delta G. And if I multiply anything, my reaction, I just multiply the delta G by the same factor. Here is smelting. Smelting is a process of taking an ore and turning it into the metal. This comes from Amazon. It's like $20 for, I think, 100 grams of pure iron. So we want to do this. And the ore, typically ores are as like an oxide compound or some sort of mineral. We want to turn it into the pure metal. That should say solid, not gas. Ores, well, they could be a solid, but it could be a gas, but not when you get it from the earth. Now here's the problem. I've got a really big delta G value. It's thermodynamically unfavorable. So what am I going to do? I'm going to couple this with another reaction that has a common intermediate. And here you can see it's oxygen. And I'm also going to couple it with a reaction that's thermodynamically favorable, as in this reaction. All right. Now, you'll also notice that if I want these intermediates to cancel out, I need to multiply this reaction by 3. So I do that. I get this. Remember Hess's law. When I multiply the reaction by 3, I multiply the delta G by 3, the delta H, or the delta S. All right, so I get this. And then if you, just like when I add these up, this is going to be a negative number. So I add, would be my overall reaction. I'm getting what I want. I'm getting my metal. And my delta G now, which is the sum of these, is also thermodynamically favorable. This is known as the process of coupling a reaction. Biology does the same thing. It's incredible that this is happening in us, where the body really wants, or the system really wants, this chemical C, but it's unfavorable because it requires some energy. It's going to couple that with another reaction, and there's two requirements. They need a common intermediate, all right? And the first reaction typically has a greater thermodynamically favorable quotient than the second one is unfavorable, in that it's going to release more energy than this one needs to take in. All right? So our cells need this molecule, this complicated molecule of G6P, and this process has to happen because we need this protein, or we need this uh, sugar molecule for the cell to function, but it's energy rich. And so we're going to couple it with a different reaction. We're going to couple it with the hydrolysis of ADP, which is it releases energy. When I couple it, my intermediates cancel, my water cancel, my phosphates cancel out, and I'm left with this overall reaction, which is thermodynamically favorable. Here are my sources. These Libre texts, which I'll put in the forum and in the are and really been very helpful. Thank you very much.